today's topic for Steam Powered ED is about coding in general, kind of what that means for education, what that means for our students. And I'm going to start with younger grades all the way down to elementary grades, where you start and work your way through up to high school. And again, this doesn't mean that you have to be teaching a coding class. Pretty much any subject area you're talking about, there's aspects of that you could incorporate this. I purposely yesterday, it was Monday, we did CoSpaces, where we talked about how, yes, it's a virtual reality environment. Kids can kind of drag and drop things into that and make worlds however you want to use them for, whatever content, but there's a little coding element to it. So it's not a case where coding is in itself. It's kind of like when you learn, different things. If you learn it for its own sake, it's not as easy, I think, to learn as it is if it's in context. So, if I'm learning math for its own sake and just for the purpose of learning math, that's very different than learning math to apply and go use that in a real context. And so we started with, kind of VR worlds, 3D models bringing in. Then we talked about Tinkercad, which is where we can build those models. And now we're going to talk a little bit about the coding, where you can actually do things with that stuff. And again, really depending on any subject area that you're talking about, I think is applicable. So we'll do a quick screen share here. All right, so here's kind of the premise. Do my students really need to learn to code? And again, this is less of a question as much as it used to be. There's a real push in the state of Maine, a really sincere push to incorporate computer science or CS into more and more aspects of students growing up. And again, I'm a little bit biased, of course, because I do technology, but at the same time, I don't think it's a case of, well, they have to know how to code, they have to become a programmer, or, it doesn't really matter. It's really the idea of that logical thinking and that troubleshooting. I see this with my own boys. If they're trying to, solve a problem, you and I know if you take the time, you kind of slowly eliminate other factors, what things it could be, and then you got to get to the point where finally at the end of it, it is something that, you've actually solved the issue. And we really want students to kind of develop that skill set, again, depending on whatever, it doesn't matter the topic, but that kind of critical thinking. So a really good analogy that I've read somewhere, I can't remember, I should give attribution if I can remember where I got it from, but the idea of coding, learning how to code is more like working out. It's like mental exercise for your brain. And the idea is not that you're going to, if you're walking along and you come across, weights on the ground, you can be like, oh, I worked out so I could pick up these heavy weights. No, you're working out so you're staying fit, and you also, doesn't matter what the problem that actually arrives, you're prepared for it. And so the idea that coding brings on is that creative thinking, that logical thinking, that troubleshooting, all these different aspects, all these different parts of coding that are just built into it inherently. Students are going to learn all those. It's kind of like, basically weight training for the mind. Another aspect of this is when you're applying knowledge. We talk about the math skills. I think it's really difficult for students to learn math skills in a vacuum, just for their own sake. And really that goes with anything, language arts, science, social studies, whatever. If you're learning it for the sake of learning it, it's okay. But if you're able to apply that information directly as you're learning it, it makes it a much more easier, I think, process for the kids. So when they're doing math and doing language arts, whatever, and those coding components of it, it's built into the process. By learning coding, you're learning math just by default. There's a great story, and again, this may be apocryphal. We're not sure if this is completely accurate, but I think it really it exemplifies what we're talking about, kind of the mindset of coding and why that would be applicable, different than just calculation. So supposedly, when Carl Gauss was a mathematician when he was very young, he was given busy work by his math teacher. His math teacher came in and said, okay, I want everybody to add up all the numbers between 1 and 100. So 1 plus 2 plus 3 plus 4 plus 5 and so forth. With the idea that, the teacher at the time, the math teacher, could read his newspaper and let the kids kind of, have their paper and pencil and take a long time to figure this out. And so he was a precocious young lad. He figured out that if I add 1 plus 99, that's going to equal 100, or 2 plus 98 equals 100, 3 plus 97 equals 100, and keep going until you get to the point of 49 hundreds, and then you have the remaining 50, which is in the middle, and then the remaining 100 at the end. So he supposedly did the entire calculation in a couple minutes, brought it to the teacher, and the teacher was very upset because that's not what he wanted. He wanted kind of time apart. But what that really exemplifies for me is, calculations computers can do. And we know computers can calculate very quickly. That's the whole point of them. but they're not thinking that kind of, logical leap to do those kind of like higher order thinking skills, where this is, as a mathematician, students would be able to figure that out. It's a very simple form of algebra, but that's where we're, applying the thinking. It's not just doing the actual calculations. And so when you think about the coding component of it, you'll learn that there are very kind of elegant ways to code, meaning that they're very simple. You can take a very complex problem and really break it down to its simplest, easiest components, and that's what you're trying to do. And that ability to do that, to take a bigger problem, break it down to simple components, and fix that one little piece of it, and then add that to another piece of it, and so forth, I think is really important for kids, the skill to have, because as we go forward, the bigger and bigger projects that kids work on, or bigger problems, or whatever it is, for them to break down the problems and focus on certain things and fix those things is super valuable. So this is one example I've done with younger kids before, as far as a project. In kind of just to introduce it, is we have a bag of Legos, like 4 or 5 Legos, all the same. We bring into a younger group, let's say 4th graders. We have them split up into pairs. So one of the pairs of 4th graders builds a thing with the Legos. And then they have an index card where they write down the steps on how they would create that thing if they would have somebody else build it. And then we break it apart, give those broken apart Legos to the other student, give them the directions. They work on trying to figure out how to build the thing. And then when they're done, you compare what it was versus what the original one was. And you realize how difficult, how absolutely, on point you have to be with the directions. You can't just say, put the red Lego on top of the blue Lego. You have to say which direction, how many pegs over, all these different little things that we take for granted as we're looking at them. But when we're actually given the directions to do it, it's really important that we're very, very precise. And again, that type of language, or that type of instructions is a part of coding, and is a part that's basically what coding is you're giving a very explicit set of directions. Now we'll go into some of the options. Again, if this is something that you're interested in having students play with, or start to integrate into what you're doing in your classrooms, or just have them play on their own, a very good place to start right off the bat is one called code.org, and that's really kind of the baseline. They have this thing called Hour of Code, and there are tons and tons of little fun activities that kids can learn, and they're mostly game-like. They're fun. They're characters they recognize, here Star Wars or Frozen or Minecraft or whatever, superheroes, that kind of thing. So kids can make these things. Again, they're pretty straightforward, pretty easy. I would start with younger kids here just to kind of get the idea of how the process works. And we do Hour of Code in our district, and a lot of students have used this before in different capacities, either with the classroom or if I'm joining their classroom to kind of learn how to play with this stuff. And that's a great place to start. That's really an interesting place to get them so that they all kind of know what you're talking about when you're talking about coding. They've seen it, they've experienced it to some degree. After the Hour of Code, kind of move on up, and then we get into CS First. Now, when we talked about the applied digital skills, or we talk about Google Classroom, these are sets where we're setting up the lessons as teachers, but there's a whole process, a whole bunch of lessons already done for students to kind of access and pull in. This is very similar. So CS First, again, you'll sign in as a teacher. I can get started here. And there are all kinds of pre-done lessons that kids can walk through. All of your students from 7th grade on, if you have 7th graders or older, have done some bit of CS First, depending on what age level they are. Because we were starting at the second half of the year this year, but certainly anyone before that have done this. And they have all kinds of different lessons inside of here. I can create a class, just like you can with all the other things, like Google Classroom or Applied Digital Skills. So I could say, you know what, I want to make an interactive presentation. So this isn't just a slideshow. This is a slideshow that's interactive, that's actually coded so it will do things. So I can view this lesson here. This will give me examples. This will give you all the different exposure that you need, all the different steps that your students would need to do this. It gives you videos. This should look very similar to Applied Digital Skills, where students can watch a video.
Hi, I'm Brendan, and I'm a former math teacher who now works at
All right, so we can walk through step by step all the different components of what you would need. Here's a starter project. Let me keep going through animation. Here's animating a sprite, adding movement, adding sound. So all the pieces, all the components, the technical aspects of it are already done for you, basically, all the lessons they would need. What you would supply is the content. Okay, I want you to do an interactive presentation about I don't know, frogs or whatever you're learning about, whatever your content is. And this just gives them a more fun way of doing it. It's the same kind of thing we've been talking about all week, is the same content, but just different, more interactive ways of exploring that content or presenting that content. And making a little presentation or interactive presentation with code is just one more way. So that was the first one. If I look back here, there's tons of different things. Here's narration, dialogue, figurative language. Some things are a little bit more animated. Name is a pretty straightforward one. This is usually the one that I do with kids to start with. So starting in 5th grade, when we do coding with them, I usually do an animated name. And the reason why is because everyone likes to have their own little piece of it. So it's not just, coding something that's for somebody else. They're putting their own name in there, and they're having it, bounce around and have the letters do different things. And so that's really what we do, just to get them so they're exposed to how it works, how the whole process works. And then after that, the next step is really whatever they want. They can actually use this for any, content. Again, they can create, programs for whoever. So that's CS First. Now, CS First uses the programming language called Scratch. That's what they use to write the code. They give you all the directions. Like I said, if I look at any of these, this will walk you through step by step any of the pieces. But the actual programming language that's connected is called Scratch. And this is Scratch right here. Let me sign in. So Scratch is a lot of drag and drop. It's a little bit more complex than the Hour of Code thing. So if I grab, let me see if I've got my name on here. I think I do. Yeah, these are just sample ones, but that's okay. This will work. So this is just an example. And this is something, like I said, from your 6th graders on up have been exposed to this. Maybe some of the 5th graders, I'm not sure all of them. But what it is a lot of drag and drop. You'll notice that you recognize these. These look a lot like the Lego kind of sets where they snap together. But there's a lot more options over here on the left. They can change costumes, meaning that your characters can actually change what they look like. Students can create their own characters. They can draw them. They can grab images from online if they want to. They can add sound effects. They can do a lot more coding, a lot more detailed things. And when they're done, they would publish this. Just regular, you'll see tons and tons and tons. I'm going to make changes here. But tons of examples of other students. And here's the cool thing about these. If a student sees one, I want to see how they did that. I'm really interested to see how they did this one project here. I'll just click on one of these to see what it looks like. So if I'm a student, I'm like, how'd they do this pen art one? I'm not sure exactly what's going to happen here. Okay, so it's going to draw, and that's pretty cool. All these different kind of, designs or whatever. You can see inside. So everyone that's on here, if I click see inside, it's going to show me the actual code it took to make that. So it's like learning how to do it from other people that are doing it live. And if I wanted to take that code and adapt it and make it my own, I would click remix right here, and it will do just that. It will take the existing code and copy it over. And so if you had a template that you wanted students to use, you could create it. They would basically make a copy of it. So they wouldn't have to start from zero. They could start from something, and then you can kind of work your way up. And kids love that. And that's really how a lot of coding works. I'm going to stop this for you here. Where it's the idea where you kind of look at what other people did, and you learn from that, and you take pieces of it, and maybe you add another piece. You kind of put all these things together to build something that you couldn't have done before. As I mentioned, it's been a little while since your students have used this, probably, like I said, 6th grade or up. But if you're interested in this, if this is something that you think the kids are going to play with, let me know. I think it's a great way to do the same type of content. So they're still learning the same content, but they're doing it in another more interactive way. This is also a precursor where what we find is about 7th and 8th grade, students using this will they'll get to the point where they kind of get tired of Scratch. They've used it for a lot. They get to the point where they've used this. They've kind of reached the limits of what it can do. They've done the 2D thing. And that's when we introduce CodeSpace and we start doing 3-dimensional coding, where it's not just flat 2-dimensional items. They're actually doing 3-dimensional things. As you saw on Monday, they're having, characters or animals or whatever move around in 3D space. And so that's kind of the next level of this. And then one other aspect of it, we jump back here, some other languages. Tinker is another one that's very similar. And Tinker works pretty much like the other one I'm going to introduce here is called Workbench. And what Workbench will do, this is Workbench EDU. It's the same idea where you're going to do a lot of drag and drop coding like all the other ones. The difference is I'm going to create a new blocky program. Is this will start tying into other physical devices. Meaning, for example, we have, I think I mentioned the other day, we're going to have some of my students are doing telepresence with using robotics, but they're going to use it from afar. I've been doing this with my STEAM class at the high school level, where they are using Chrome remote desktop to connect in, called VPN, virtual private network, to VPN to a computer here at my house, and they're controlling robots here from afar. And the reason why we're doing that is, again, it has all these different pieces of it. One, it has coding in it, of course. It also has a very realistic problem. If you are coding robots that are, on Mars or on underwater or somewhere else, telepresence, that's how you have to do it. There's a lag there, and you have to kind of plan for that. So it's been fun having the students learn, how to make that work. We have the video cameras here, so they can see different aspects of what they're working in. But that's just a way to kind of really kind of practice of what it would be in real life. So there's a bunch of different physical, actual robotic kind of pieces here. These are all different things. There's buzzers, there's proximity sensors. Here's the motors right here. I'll just show you what that would look like. So if I had, grab this one right here. So this program, again, you notice it looks a lot like all the other ones. It's very much drag and drop. But this DC motor would be connected, and I can say, okay, when I start the program, this motor is going to turn. How fast is it going to turn? From 0 to 100. I'm going to say it's going to turn 50, which is kind of halfway speed. So it's going to turn 50. And then when it, when the other sensor stops it, it's going to stop or whatever. You can kind of play with that. And so right now we're in the process of kids building the programs and then actually running them on the actual physical components to see how that works. And so again, in this hierarchy, we started at very simple kind of gamified versions of this. Then we get into a little bit more complex where kids are actually making two-dimensional codes to, for their other content areas. And then it get to the point where they're actually coding things that are actually physically moving in real space. So there's a hierarchy there. And most of the students that you work with have had some exposure to this. All the students that have gone through IT certainly have. If they get to the point where they go beyond what's available there, they're like, okay, I've done all this. I'm ready to go even more. They want to start developing mobile apps, for example. MIT App Inventor is a great free. These are all free, by the way. All these ones I'm showing you are all free. Again, this is a little bit self-run where students will kind of go on themselves and kind of work their way through this. But this gives you everything you need to do to make your own mobile app. Now, this is not iPhone. This is just for Android. And the reason why is because this is free. You can install it on an Android phone for free, no problem. They have iPhone or iOS versions that you can do that, but it's $100 for a developer license. So usually students will just use the free one. They could run it as a mobile app. They could even run it not only on their phone, but if their Chromebook can be turned into tablet mode, we talked about that, where they flip over, they become a touchscreen tablet, they can install their app that way and run it there. So if they want the touch interface and do that. So this is a great free program. Kids can play with MIT App Inventor, just like it sounds like. They're using they're basically using Android to be able to create apps. It's a next step up. It's not so much, there's not a lot of hand holding going on. You kind of have to figure out yourself, but it's a next step up beyond the stuff that we've been showing you so far. And then the final thing is we could kind of scroll down here, Code Academy. Code Academy, if you have students, probably most likely at the high school level, that are really interested in hardcore coding. They want to learn how to code, to do that for a profession, to kind of go beyond just kind of what I need to do to solve a problem, instantaneously. Code Academy is a fantastic resource. They have tons of different languages on there. As you know, there are tons of languages, possible languages that students can use. The thing I like about Code Academy is after they've chosen their languages, this one is not free. Now, it's free right now because they're allowing students to use it, but generally speaking, it's not. But if you do go on and if you do choose a language, let's do the Python one here. What I like about it is as you're going through the steps, it's actually showing it to you over on the right side. It's showing you an example of what it looks like while you're coding it. So if you are serious or you have students that you think are serious about coding, learning how to do that, the Code Academy is a fantastic resource to be able to kind of start that. One other one I'm thinking of it that I should mention, they have introduced some coding aspects to Khan Academy. So again, it might be another place for kids to just kind of play with and start to. These would be more serious students, ones that are interested in really doing coding. They're not just there to kind of mess around. The last one I'll share, and this is one that, again, depending on what your needs are, this one a lot of kids wouldn't find super fun to play with because unless they have a need for it. But if you're interested in something that you want to learn a little bit of coding, you want to do something that's useful that I could use tomorrow, the Google Script is a really great one because we use the tools all the time. If you need to develop a mail merge, or if you want to do something, for example, we're using one right now at the high school level. the teachers are filling in a Google form to be able to create certificates for the end of the year, like the awards and certificates and that kind of stuff at the end of the year. Well, we scripted it so that it would take that information and create PDFs out of it that the secretaries can print out. And so that process is basically using Google Script. So if you're interested in that kind of thing, again, this is stuff that we would use every day, probably. That would be useful to you as far as an option. All right. Let's jump to see if there are questions. I don't know that a lot of people in this chat right now are going to be into coding. Good question from Nate. Do our districts do robotics or have a robotics team? The short answer is we do robotics in the STEAM lab class. I've been doing robotics with the kids for this year. They all do robotics in 7th and 8th grade with IT. Every student has done Lego robotics and some other robotic kits. We have not had a Lego team in the past, simply because the IT, if you know Keith Kelly, my brother Keith, he would go from one half of the year to the other half of the year to 2 different middle schools. And so this was going to be the first year there's actually the same school all year. And the reason why that's so important is the robotics team, the Lego robotics kits that we have that would go for that team, actually apply. You actually need to be in one place all year for that to work. And so going forward, probably starting next year, again, depending on the situation, if we're in school, is we will be able to actually have a robotics team that will work all year. And so we've had students interested before. We've done little things, but we've never had a formalized one that I could see us, now that we're in one building, we'll be able to do that, have a robotics team, which will be super fun.
That's cool. Thanks.
Yeah, absolutely. So I think with that, are there any specific questions from you guys? I see we've got, let's see, we've got Gail and Kathy and Mila and Nate. I just want to talk about coding, just kind of wrap up this week. We've been talking about some of that kind of extra stuff like, 3D printing and coding and, modeling, whatever. We're going to start next week. We will not have a session tomorrow. I've got a meeting with the DOE tomorrow during the same time. But next Monday, we'll start again. We're going to kind of go back to basics. Some of the things in the Google Suite have been changing over the last couple months just because obviously they're adding new features and they're really gearing it towards education. So I want to start over again, basically on Monday, not from zero, but start and kind of revisit some of the things that we've talked about before so that we can kind of talk about what changes have been made. There's a couple of changes that came up in Google Drive this last couple of weeks, so I want to talk about those and basically start over again and make sure everybody's at the same page. And hopefully I will be able to share the 360, yes, and hopefully the 360 images. Like I said, my plan is to have that ready for Monday. I think I'll be able to, and be able to share that out with everybody so people can kind of go do virtual tours of the old school, which will be kind of fun. So I think with that, if there's no questions, I didn't have any in the Q&A today, but I think with that, I'm going to wrap it up. So thank you guys, and I will see you on Monday.